Hi, today we're going to talk about the bridge that was supervised by Dr. Najman Jamal Mustafa. This bridge was made by Team 1, which included Yusuf Muhammad Abu Futuh, Ziad Muhammad Ghanem, Ahmed Yasir Hussein, Basan Said Nagor. The first step in this project was finding a design for the bridge. To find the design, we had to see all types of bridges that can be executed. At first, we found the cantilever bridges that are built using cantilevers, horizontal beams that are supported on only one end, but we couldn't make this using the materials that we had. So we looked more and we found the arch bridges, which are arch-shaped and have abdomens at each end. The weight of the bridge is thrusted into the abdomens at either sides, but we also couldn't do that using the materials, so we looked for more and we found the suspension bridges. Suspension bridges are suspended from cables, and the cables hang from towers that are attached to copper dams, but we couldn't use that because we couldn't use wires. We only had sticks and glue. So we looked more, we found beam bridges that are horizontal beams supported at each end by pairs, but we wanted to find a more suitable bridge. So we looked more, we found the cable stayed bridges, which are like suspension bridges, so they weren't working out until we found truss bridges that are made that are composed of connected elements. They have a solid deck and a lattice of pen jointed grinders for the sides. So we decided that we're going to make a truss bridge. After that, we were looking for inspiration because we can't start a model without having inspiration of a pre-existing, a very successful model. So after looking in most of the countries and all of the truss bridges that we could find, we found the perfect example, which was Allen Bridge, and we took so many designs from it, and we were inspired from it.
And now for the construction part. We started off by simultaneously building the two supports in order to save time, as while the left support's glue is left to dry, we were building the right one. The supports are 10 centimeters in length, and they are in the shape of squares, with a center line of symmetry for additional strength and resistance to breaking under the testing and loading phases. Secondly, the trusses. We made sure that the trusses were in the form of continuous connected equilateral triangles with no zero force members in order for the trusses to function at maximum efficiency, however, if it is compression or tension. Each triangle was constructed individually, and then they were all assembled together using the glue for support on each side of the bridge. Third was the roadway. We first glued sticks together next to each other by their cross-sectional surfaces by the length of the bridge, leaving only 2 by 2 centimeter gap for the loading area. Then we covered the layer formed in step 1 by sticks connected only by their thickness to form the roadway for the tow truck to move on.
The next phase is the assembly phase. The two truss chains were connected with the road using the glue to form the bridge, connecting the part in the previous step to the two supports and adding a fence to the bridge in the form of triangles, which can save cars from falling off. The final look at the bridge. Finally, after all these stages, the bridge came to its final shape. The bridge relied majorly on the laws of pressure and the understanding of trusses. By combining both, the team could successfully generate a two-layered bridge, one layer for cars and the other for pedestrians. The bridge can withstand a large amount of weight. That's why it offers a multiple method of transportation. You can use your legs, bike, or even a car. In this image, you can find a panorama of the cars, pedestrians, aka Smurfs, وفي close up the corresponding picture and the shape of the bridge. Problems and solutions.
تمام. اول مشكله قابلتنا مشكله الزيرو تراس. مشكله الزيرو تراس بالنسبه للبريدج ان هيبقى فيه بوب ستيكس محسوبه ويت للبريدج، وفي نفس الوقت مش هيبقى عليها لود او فورس هتاثر عليها. تاني مشكلة قابلتنا مشكلة الأورجنايزيشن، هنبتدي بإيه الأول أو هنعمل إيه الأول. تالت مشكلة قابلتنا مشكلة الجاب اللي هتبقى على الرود واي. تمام، نيجي للسوليوشنز. أول مشكلة قابلتنا زيرو تراست. السوليوشن بتاعها اللي احنا كنا المفروض نجيب نختار أسهل شكل ممكن يتعمل بالبوب ستيكس. تمام، وفي نفس الوقت يبقى الممبرز يبقى effective بالنسبة للتراست، أو ما يبقاش فيه زيرو تراست ممبر. تاني حل لمشكلة الأورجنايزيشن اللي أنا حطينا بلان قبل ما نشتغل، احنا هنبتدي بالسبورت، بعديها التراست، بعديها الرود واي. تالت مشكلة قابلتنا مشكلة الجاب اللي على الرود واي اللي هيتحمل عليها اللود. فقررنا ان احنا نعمل الجاب قبل ما نجمع البوب ستيكس مع بعض. نيجي للكونستراكشر ستيجز. أول حاجة احنا بدأنا بالسبورت. السبورت بيتكون من 4 سيمتريك سكويرز بحيث اللي هو يشيل أكبر لود ممكن. تاني حاجة عملنا التراس هيبقى شكل ايكولاترال تريانجل. عملنا كل تريانجل لوحده، بعديها جمعناهم مع بعض في 2 تشينز. بعد كده عملنا الرود واي، خلينا الرود واي للآخر بحيث اللي هو المفروض أكبر لود يتحمل عليه، فخليناه للآخر. وفي نفس الوقت عشان يبقى نعرف ايه الويت اللي باقي، ونعرف نستغل كل الويت اللي ناقص من 1 كيلو في الرود واي. وعملنا في الاخر رايت انجل تراينجل تبقى بالنسبه للبريدج فينس، وفي نفس الوقت تبقى تراس ممكن تشيل اللود حتى لو كان خفيف. ودي الصور المفروض تبين لنا او تبين الستيجز اللي احنا كنا عملناها. تبين الستيجز اللي احنا عملناها عشان نبني البريدج.
آخر حاجة حابين نثانك دكتور نجوان. thank you for your time and hope you are impressed by our hard work. We hope you are impressed by the efficiency and the coordination between our team members. Thank you and goodbye.